Okay, hello everybody, it's Algebra 1. We're getting ready to do lesson 1.5, which is using a problem-solving plan. And I'm going to do part 1. If you need part 2 or maybe part 3 of this, email me here for worksheets, etc. 1.5, use a problem-solving plan here. Got extra classwork, staple it to your classwork sheet. If you're an online student, make sure you include that in your work when you send it in to me. Notebook, 6 points, and then classwork, you got a 26-point skill sheet for classwork. Okay, teachers, for the bell work, if you're a homeschooler or a classroom teacher, this is your bell work today. They have what are the dimensions of each fabric square, how many square inches of fabric do you need if you want to include 48 squares. Here's your situation here, students. Give your students 5 minutes to do this. Okay, welcome back. Students, hopefully you got this done here. Here's A. So this is the amount of each fabric square should have a side length of 7 inches here for that. And then for B, the area equals S squared, side squared. So this will be a situation here. You need 2,352 square inches for that. Okay, use a problem-solving plan. Use problem-solving strategies before to solve problems, word problems like the bell work. You will use a problem to solve some problems here. So, problem-solving plan. Read and understand. Read the problem carefully. Identify what you know and what you want to find out. Make a plan. Decide on an approach to solve the problem. And 3, solve the problem. Carry out the plan. Try a new approach if the first one isn't successful. And 4, look back. Once you obtain an answer, check that it is reasonable. Okay? So, read a problem and make a plan. Example 1 here. So we got you run in a city, short blocks are north-south and are 0.1 mile long. Long blocks are east-west and are 0.15 mile long. You will run 2 long blocks east and a number of short blocks south, 2 long blocks west, and wow, back to your start. You want to run 2 miles at a rate of 7 miles per hour. How many short blocks must you run to supply for that? Well, here is a diagram here of this situation up here. Read and understand. So what do you know? Well, you know the length of each size of the block, the number of long blocks you will run, and the total distance you want to run. So you know that. This is what. Here's a diagram. You can conclude that you must run an even number of short blocks because you run the same number of short blocks in each direction. What do you want to find out? Well, you want to find out the number of short blocks you should run so that along with the 4 long blocks you run 2 miles. So we want to run 2 miles as our total run here. Use what you know to write a verbal model that represents what you want to find out. Then write an equation to solve it as in example 2. So, okay. What if in example 1, suppose that you want to run a total distance of 3 miles. How many short blocks should you run? So instead of 2, you want to run 3. And then here, you make dog collars, anticipate selling all of them, blah, blah, blah. This is yours, students, to solve. You've got to practice 3 miles now for that run. Here's your setup. 0.1s plus 0.15 times 4 equals 3. So here's our long blocks here, and we're going to run 4 of those. So we need to know how many short blocks we need to run to make 3. So 0.6, we do our algebra here, guess the number easily multiplied by 0.1, like 30. Or you could just move this over to here. 0.1 times 30 plus 6. I mean, I'd move this over here, but okay. 3.6 does not equal 3. 30 does not check. Try 24. So we're going to stick in 24 in here. And then 24.1 times 24 plus point. Now that does equal 3. So 24 times 0.1 would equal 3. 3 equals 3, 24 checks. So that'd be a problem-solving kind of a plan. Okay, so that was fine. Okay, our next guy practice here. In example 1, well, we already did this one, didn't we? How many short blocks should we run? Well, maybe there's another way of solving this. Oh, we're going to solve our independent practice. You're lucky. It's your lucky day, student. Ding, 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 ding. We're going to help you on this one here. The independent practice. You know the number of colors made, amount of money spent on materials, the amount of profit you want to make. So therefore, you need to find out the amount you have to charge for each color. So that after subtracting 85 in expenses, you still have $90 left. I mean, that's a big up for you, students. Okay, that was 1.5, part 1, Algebra 1. If you need part 2, email me here. Thank you.